Hey guys, hi, this is Abhishek, Master Teacher of Physics at Vedantu. How is everyone doing? Give me a quick high five guys, give me a quick high five. High five to each and every one of you. You have been doing amazing for the entire sprint text. I have been going through each and every comment and all of you guys are wonderfully doing, and I could see the homework which you guys are submitting on the comments. It was super proud moment that when you guys do your homework and put down the comments as well as send your emails, I believe I've replied to all of them. If I have not, I'm really sorry. I'll be replying to all of them as soon as possible. लेकिन यार बहुत मजा आ रहा है in this sprint text also. The response in this sprint text is way more amazing than the first sprint text. That means it just means that more and more students are getting together as a family with us, isn't it? Thank you so much guys. It's all is happening only and only because of each and every one of you. Thank you so much once again. So my dear students, we are back onto the physics session for the session 5, whereas each and every one of you know that we are going to run like him, we are going to sprint like him, and we're going to cover up one of the most important Vedantu sample paper today. Now we have covered in the previous session 2018 previous year board question paper. We have also covered up one very interesting 2019 CBSE sample paper, obviously released by CBSE, and in today's session we are going to cover up the Vedantu sample paper. So if in case you have not seen the previous videos, I recommend you guys to go and see it because we have covered some very easy and very interesting questions, but also pretty important of them. Cool. So let us try to understand what is given in the Vedantu sample paper and what is the marks category. We'll be following the same routine. Let's not change our the routine which we follow. That is nothing but we'll be starting with the concept of light, reflection and refraction, and the entire system follows the same routine of 7 marks for light, which is completely true, which we noticed in all the other papers also. Followed by human eye and the colorful world, which obviously carries 5 marks, followed by electricity, but here we have increased the questions in the part of electricity. I'll tell you the reason why. Electricity is for 13 marks straightforward. After electricity, we're going to go forward for magnetic effects of electric current, which is going to come for 3 marks. Now, if you notice very clearly, electricity का जो marks है, it is supposed to be somewhere about 8 marks, but we increase it to 13 marks. That is the reason why, because we have not included any sources of energy in this particular sample paper. क्योंकि हमारे हिसाब से we have done so many videos and we have done in the previous sessions also of 2018 and 2019 CBSE board sample paper, we have covered some very crucial questions from source of energy already. So we thought let's invest more time of the one of the most scariest chapter of each and every one of you, which is nothing but electricity. तो हमने सोचा इस पे ध्यान देते हैं ज्यादा क्योंकि सोर्स ऑफ एनर्जी तो बच्चों को हो जाएगा. Correct? Yes guys, so that is the reason why we are not taking source of energy here, but yes, electricity will be doing for 13 marks, but in today's session focusing only on these 2 topics for this particular session. Cool? Let's go ahead guys, and before the start, as every one of you guys know, we are gonna share a very interesting quote which looks like that: hope for the best, expect the worst, because life is a play and we are all unrehearsed, isn't it? So I'm gonna repeat that again. You should always hope for the best and dedicate yourself and be determined for the best that is going to happen. And if in case you do not hope for the best, expect the worst at least. क्योंकि यार बुरे से बुरा हो सकता है, अच्छे से अच्छा भी हो सकता है, लेकिन if you are prepared to handle anything in the entire world, then who is going to stop you next? Isn't it? So just be motivated guys and completely be confident in yourself, because that's what ultimately matters. Cool? So going ahead guys, right now let's go and hit that first question with this particular quote in our mind. We are going to expect the worst. Here is the question number 1. Now this question carries straightforward 2 marks from this particular chapter, that is human eye and the colorful world, and it's one of the most confusing questions for a lot of the students out there, isn't it? ध्यान से पढ़ना. The far point of a myopic person is 150 centimeter. What is the nature and power of the lens used to correct the defect? Easy? Looks easy? Yes, it is easy. It looks easy and it is easy. Let me explain you कि इसको कैसे करना होता है. Many of the students might not have ever seen human eye का numericals, लेकिन बेटा ये human eye से आता है और ये बहुत ही interesting सा question है. And many of the students might go wrong here because they do not know one very small interesting concept जो मैं बताने वाला हूँ. ठीक है, so let's go ahead guys and try to solve this question. It's a 2 mark problem. You can invest 2 to 3 minutes in examination, but यहाँ पे we'll be investing only 1 minute. So let us try to focus on the key points here. Okay. The far point of a myopic person. First of all, the moment they say myopic person, what should come into your mind? You should get in your mind कि कौन से type का lens होगा. Since it's myopia, it's obviously going to be concave lens, straightforward. is 150 centimeter. Okay, there is a concave lens. Let's not talk about lenses now much, क्योंकि यहाँ पे पूछा गया कि what is the nature, तो nature में इसका आंसर हो जाएगा कि concave lens है. And what is the nature of concave lens? Nature of concave lens is it's a diverging lens. Simple, straightforward. करेक्ट? बस तो एक मार्क आपको यहाँ पे मिल गया. नेचर के लिए आपको एक मार्क मिल चुका है. ओके, लेट्स रीड द फर्दर पार्ट. नाउ इट इज स्टेटेड वी नीड टू फाइंड आउट द पावर ऑफ द लेंस टू करेक्ट दिस डिफेक्ट. ओके, पावर इज इक्वल टू 1 by f when f is in meters. So ultimately we don't know focal length. Some value is given, 150 centimeter. What is this value, guys? Is this your object distance or is this your image distance? This is the most confusing part for a lot of students here कि 150 centimeter जो दिया हुआ है, it's been stated is the far point. So this should be object distance or image distance. Let us talk about that for just 1 minute. When we talk about myopia, what is myopia? Myopia is nothing but short-sightedness. That is, you can see everything nearby, but you cannot see everything which is far away. For example, when an object is kept at infinity, that is the far point of a person. कि मतलब जहाँ पे object, no, for a normal human eye, if an object is at infinity, you see an object very clearly which is at infinity. Why? Because the object is at infinity and your image is also formed at infinity. So it's pretty clear to you, okay, my eye is normal. So that means in this scenario, the object is at infinity. Stated? Okay. Now, for a myopic person, what happens? For a myopic person, when the object is at infinity, he cannot see the object, or for him, the image is not formed at infinity. The image is formed before infinity. This is myopia. मतलब उसको clearly दिखता इसलिए नहीं है क्योंकि image is not formed where the object is. If object and image collide with each other, then you see a very clear image. But if they do not collide with each other, an object is behind and image is in front, this is what you call it as myopia. तो यहाँ पे कहा गया है that the far point of a myopic person is 150 centimeter. मतलब 150 centimeter पे उसका इमेज बन रहा है when the object is at infinity. So what is this 150 centimeter? This is V. Simple scenario. This is the clarity which you need in your mind. Whenever in the numerical far point or near point comes, it's always image distance. It is not object distance. Cool? Okay. Very simple clarity now. Now you know what is U, what is V. Now comes the sign convention. Let's talk about the spectacles. When we talk about a concave lens, my dear students, think and tell me, does it ever give us a real image? The answer is no. The answer is no. It never forms a real image. Concave lens always forms a virtual image, and for the case of concave lens, that means I should get U also negative and V also negative, because it will be, all the things will be on the left hand side, and yes, that's how it is. So your U and V should be negative in the case of myopia, and in the case of myopia, the far point will be 150 centimeter or whatever centimeters given in the question. Simple scenario. अब हम आगे बढ़ते हैं, because now it is very easy to find out the focal length, because we know U and V. With the help of lens formula, we can find out focal length very easily, isn't it? Yes. Let's go forward, guys, right now. ठीक है, अब मजा आएगा, अब तो बहुत easy हो गया question. अब आगे बढ़ते हैं. So 1 by f is equal to, I hope you can see this. Yes, 1 by f is equal to 1 by V minus 1 by U. हमें find करना है focal length. So 1 by f will be equal to, what is 1 by V? 1 by V we already stated, 1 by minus 150 minus of 1 by U. What is 1 by U? Negative infinity. So minus infinity. It doesn't matter it is negative infinity or positive infinity. 1 by infinity is straightforward 0. Correct? You divide 1 by infinity, it will give you 0. Yes. So now you have 1 by f is equal to 1 by minus 150, and your answer would be focal length is equal to minus 150 centimeter. That's your answer. क्या चाहिए और? Now we have the focal length here. We need to find out the power. Power is equal to what? Power is equal to 1 by f. Now what we will do? You will take power is equal to 1 by minus 150 centimeter, isn't it? No. This is the second mistake which you can do here. My dear students, 150 centimeter बिल्कुल मत लेना, क्योंकि वो सेंटीमीटर में है. The reason why is that? Because power's SI unit is diopters, and it is in diopters when focal length is in meters. So what you will do, you will convert this 150 centimeters into meters right now. So power will be equal to 1 by converting it to meters, 150 को meters से convert करो, आपको मिलेगा 1.5. So minus 1.5 meters is the answer. 1 by 1.5. What is it? Nothing but we can write down 1.5 as 3 by 2. So बन जाएगा 2 by 3. So 2 by 3 negative meters. I always tend to convert this to conversion. मतलब मैं decimal मैं fraction में ले लेता हूँ because it's easy for me to divide now. Correct. 2 by 3 I know the answer. It's straightforward. Negative 0.6667 diopters. It will keep on going at 0.666666. उसको मैंने 0.667 diopters लिख दिया. आप चाहे तो इसको directly you can write it down as 0.67 diopters. That is also damn perfectly correct. Very good, guys. What are the things which we take from this question? Let's revise it quickly once again without any more delays. What do we notice? We notice whenever the point of myopia comes, the lens will be concave. If it is a concave lens, you will be negative, we will also be negative because concave lens always forms a virtual image. Scenario, correct? Done. In the question, if it is given that the far point of an object is this, that far point is nothing but the image distance, it is not the object distance, because now we are clear, object distance in the case of myopia will always be infinity. Repeating again, will always be infinity. Okay, let's keep this in mind. Okay, then we'll go forward and try to do the question. As simple as that. अब मैं एक बात पूछना चाहता हूं आप सभी लोगों से, ध्यान से देखना यहाँ पे. If I replace this 150 centimeter with 80 centimeter, what is the focal length you're gonna get it? You got it right? Exactly. You're gonna get it as minus 80. क्योंकि infinity तो हर बार आपको मिलता रहेगा आपको. U is 1 by infinity always, isn't it? So you'll get minus 80. Okay. Now if in case I'll change it to 40 centimeter, what is going to be the answer? You'll get f is equal to minus 40. Yes. So can I write this down directly that power is equal to 1 by minus v? Can I write that down? It's pretty simple because what is f? Image distance दिया है आपको 150 centimeter. F is negative of that image distance. So can I write down as P is equal to 1 by minus V? I think I can. So if this question instead of 2 marks comes for 1 mark, you can just directly use that formula instead of finding this focal length. क्योंकि इसके लिए आपको already marks नहीं मिलेगा अगर ये 1 mark का question होगा तो. So you'll not get marks for this. You'll only get marks for this particular part. So I'm giving you a shortcut how to do the same problem for 1 mark if this question comes for 1 mark. Cool. You can directly use that P is equal to 1 by minus V because ultimately what is F? F is equal to minus V only. इसलिए मैं F के बदले में minus V लिख सकता हूँ. Simple? Yes. I hope that you got that point. People who got it, amazing यार. बहुत मचा रहे हो, बहुत बढ़िया. I'm really enjoying this. I'm really happy to bring you guys a very good question here. So very nicely done. So my dear students, if you still have a doubt on this, do not worry because we have covered that up also. आप यहाँ पे पूरा solution देख सकते हो and you can very clearly see it is minus 0.66D. That is concave lens, which is the damn correct answer. So awesomely well done guys. बहुत बढ़िया. तो अब चलते हैं, हमने myopia समझ लिया अभी. Cool. We have understood myopia. Hypermetropia is left. Let hypermetropia do not feel bad कि we have not taken in the Vedantu sample paper. Let us take that as well. Let's rock that as well. And here is the question. Now this is the part where a lot of students go wrong. So let me tell you what are the pros and cons and where and all you can do a mistake here. ठीक है? But notice this damn question is for 3 marks. लग रहा है ये एक्चुअली 3 मार्क्स का है, 2 मार्क का नहीं है, ये 3 मार्क्स का है. वहां पे लिख रहा है मेरे को 3 मार्क्स है, 2 मार्क्स का है ही नहीं क्योंकि ये बहुत डिफिकल्ट है. नहीं, बहुत इजी है, समझना डिफिकल्ट है तो समझा देते हैं हम. ठीक है, पूरा फुल कंसंट्रेशन के साथ यहां पे नोटिस करना कि व्हाट आर वी गोना डू. इफ यू हैव अंडरस्टूड मायोपिया देन हाइपरमेट्रोपिया इज अ पीस ऑफ केक. लेट मी टेल यू दैट. Okay, let's read the question. Let us try to understand. The near point of a person. Okay, the moment they say near point and they say hypermetropia, we know which lens they are going to use. They are going to use convex lens. Damn well, yes. Understood. Okay, is 75 centimeter. In the previous question itself, we stated very clearly whenever we are talking about far point or near point, this value here is the image distance. We did or not? Yes, we did. So your image distance in this scenario is going to be 75 centimeter. Sign convention we'll talk later. ठीक है? Obviously, now when we are talking about this scenario, I think we need to explain this again in the same concept of myopia. समझा देते हैं. What does this near point mean? This near point means basically for a normal human eye, when we keep the object at 25 centimeter, which is the nearest point for us without any strain, which is called as the near point of the normal human eye. When we keep an object at 25 centimeter, we will be able to see that object very, very clearly if the image also formed by the eye exactly coincides with it. So you get 25 centimeter here, you get 25 centimeter here, and you are able to see the object very clearly because if the object image distance is formed at the same place. Awesome. What happens to hypermetropic people? You can take a real life example. If you have a grandmom or a granddad, you must have noticed if they have hypermetropia or if you have hypermetropia, without the spectacles to see objects, what do basically is they extend their hand out. Correct ना? मतलब ऐसे देखते हैं. मतलब क्योंकि उनका इमेज जो है पीछे बनता है. Correct? They see clarity in their object when they are keeping their hand far away. ऐसे ही देखते हैं हमेशा. Correct ना? Exactly. What is the reason behind that? The reason is if we try to keep an object at 25 centimeter for a myopic person, the image will be formed behind the object here. क्योंकि उसका उनके आंखों में hypermetropia है. So image will be formed behind somewhere at 75 centimeter. That's why they keep it behind, so that the object is now at 75 centimeter, image will be formed at 75 centimeter, and now it's pretty clear. So this is the basic reason, guys. This is what we need to understand very clearly. So ठीक है, तो आप clear हो गए कि image distance 75 centimeter है. So what will be the object distance? It is now also predefined. In the case of myopia, object distance is always infinity. Here the object distance, it's always assumed is equal to a 25 centimeter. Chill, simple scenario. Now one very interesting to understand. Sign convention. If you are okay with sign convention, then you are good to go for any kind of a question, for any kind of a numerical coming for human eye. ठीक है, अब मैं बताता हूं. The object is in front of me. That is on the left hand side of the lens. That is on the LHS of the lens. Correct? Convex lens है, ये powerless lens है, फिर भी समझ लो कि ये convex है. तो मेरे सामने object रखा हुआ है on the LHS. So object distance must always be negative. Where is the image formed? Is the image formed behind me or behind the lens? I don't think so. Image is formed exactly where the object is. That is in front of the lens. That is in front of me. So what does that mean? अगर object यहाँ पे है, image भी वहीं पे है. So my dear students, V is also negative. This brings a key point in our minds. A convex lens also in the case of hypermetropia gives me a virtual image in front of me. That is the reason why U and V both are negative. A very small key concept which you must have to understand very clearly. So I hope you got that point. We'll do a quick revision at the end as well again. Okay, now let us move forward, guys. Now we have U and V. We can proceed with our calculations. So we need to find out what is the power. So I'm pretty sure the power will be focal length. हम find कर लेते पहले. So it will be 1 by f is equal to 1 by v minus 1 by u. So 1 by f is equal to what is 1 by v? 1 by v stated 1 by minus 75, negative, negative, positive. So 1 by 25. ठीक है, minus 25 था, ये negative और negative cancel, positive हो चुका है. So 1 by f is equal to 25 minus 75 divided by minus 75 into 25. So your answer would be 1 by f is equal to minus 50 divided by minus 75 into 25. So 25 ones are, 25 twos are. You have got focal length is equal to negative negative cancel, positive 75 by 2, which is nothing but equal to 37.5 centimeter, a positive value. A very important thing to notice here right now, my dear student, is 75. It's a positive value. You must get a positive value for the case of focal length because it's convex lens. According to sign convention, the focal length of a convex lens must be positive. Same way, focal length of a concave lens should be negative. Cool? Done? Super set. Awesomely well done, guys. So f is equal to 37.5 centimeter. Done. Going to find out the power now. The power will be equal to what? I'll be taking 75 by 2 instead of 37.5 because I think that's easy for me. So basically, power is 1 by focal length, but in meters. So converting this into meters, 75 by 2 centimeters था, तो मैं लिख दूंगा 100 divided by 75 by 2. That is also possible with me. Correct ना? we know all that, we are already past that. So it will be 25, हाँ कर लेते हैं. So 25 4s are 25 3s are, तो ये ऊपर क्या हमें मिल गया 4 2s are 8, 8 by 3, and 8 by 3 I'm pretty sure it's going to be somewhere about a positive of 2.667D. Simple scenario. Correct. Now let us talk once again what and all do we take from this particular question. Whenever we talk about near point, it is the image distance. We very clearly have the clarification. Done. If it is hypermetropia, it is convex lens. Done. U and V will be negative in this scenario also, because convex lens as well gives me a virtual image, because the object is in front of me and the image is also in front of me. Done. Stated? Okay, then next is nothing but calculation. At the end, focal length should be taken as in meters, not in centimeters, for the power calculation. If it is a convex lens, focal length and power should both come as positive. If it is concave lens, focal length and power should both come as negative. Correct, guys? Amazingly well done, guys. Give me a huge high five. I think I should give you guys a huge round of applause for this particular part. तो एक बार बहुत बड़ी तालियां हो जाए, guys, because you all did really great. These kinds of questions are super confusing for a lot of students. If you guys have got it, let me know in the comments down below after this particular video कि हाँ sir, आज तो समझ में आया कि ऐसे क्वेश्चंस कैसे करने होते हैं. ठीक है, बिल्कुल बताना है. आई एम लुकिंग फॉरवर्ड फॉर दैट. ओके गाइस, सो वेरी वेल डन. एंड इफ यू गाइस हैव सिमिलरली हैव एनी डाउट्स रिगार्डिंग दिस, लेट मी नो इन द कमेंट्स डाउन बिलो. यू नो आई रिप्लाई टू देम personally, you know that, right? Isn't it? Okay, great. Moving ahead, एक बार चेक कर लेते हैं आंसर एक बार, क्योंकि देखना बहुत जरूरी है. Yes, 2.66D is the correct answer. 37.5 centimeter was the image distance, and here's the calculation. All these things you can download on the Vedantu's Doubt app. You will be provided with the link on the descriptions below, so don't worry about it. Going ahead, guys, right now, straightforward jumping into a 5-mark question from the light chapter. ठीक है? And this would be the final question for today. 5 मार्क्स का क्वेश्चन है, बहुत स्ट्रेट फॉरवर्ड, और ये रे डायग्राम्स क्वेश्चन है. आई थिंक इन द प्रीवियस सेशंस वी वर नॉट एबल टू कवर वेरी clear picture of ray diagram questions coming in the examination, so we thought why not give it here in Vedantu sample paper. It's a very interesting ray diagram question. It's coming for 5 marks straightforward. I'll tell you ki how can you divide the marks here so that it's pretty clear. Even if the question comes for different marks, how will you be able to do this? Cool. Okay, now it's stated. Draw a ray diagram for the following positions of the object placed in front of a convex lens. Between the pole of the, it's a convex lens, तो यहाँ पे मिरर के बदले लेंस हो जाएगा. ठीक है? So okay, very nice. तो यहाँ पे between optical center हो जाना चाहिए basically. So it was stated between the optical center of the lens and the focus. Obviously बात है, बहुत easy सा क्वेश्चन है, and this is the only scenario when a convex lens forms a virtual image. तो बना देते हैं यहाँ पे very clearly. तो ये आपका ऑप्टिकल सेंटर है, सॉरी ये आपका कॉन्वेक्स लेंस है, ऑप्टिकल सेंटर है, ये F1 है, ये C1 है, this is F2 and this is C2. This is the only case in the entire scenario of lenses and mirrors, if you know that when the object is in front of the focus or front of F1 and between optical center, you get a virtual image. So if I go forward for this scenario, the object is kept here. अब बना देते कैसे बनाना है, बहुत सिंपल सी बात है. चलो अब I'll take the first ray parallel to the principal axis, it will pass to the focus. I'll take the second ray passing to the optical center, it will go undeviated. Now both of these rays might be a bit diverging because they are divergent rays right now, they are not going to intersect, so we are not going to get a real image. So what do we do here? We project it backward. So when we project it backward, here is where we get the image. Correct? तो आपका image बनेगा exactly यहाँ पे. And this is true because convex lens always will give you a magnified virtual image, which is a clear straightforward statement. That is the reason why magnifying glasses are also made up of convex lenses, because you keep the object so close to the object, you place the glass so close to the object that it creates a virtual image which is magnified, and you see it magnified. That's why it is called as a magnifying glass. Correct? Great job. Now so part A is done. Let's go to part B. Between F and 2F. Again, simple scenario. If the object is kept between F and 2F, let me have a very clear picture. Optical center F1, C1, F2, C2. मुझे पता है रे डायग्राम्स में कि अगर ऑब्जेक्ट रखा है F and 2F के बीच में, it's basically the mean F1 and 2F1, the image will be formed between F2 and 2F2. So my mistake, it will be formed beyond 2F2. Correct? Simple scenario. So if the object is kept here, image is formed real and inverted here. तो मैं अब इसको पुश बैक कर लूंगा क्योंकि ये मैं करता था एग्जामिनेशन में. Many students, what do they do is basically they draw this first, then they draw the diagram, and then they find the intersection point, then they do it. तो इसमें क्या होता है, कभी कभी intersection point वहां पे कहीं पे मिलता नहीं है जहां पे आपको चाहिए. तो what we used to do is basically we used to draw both the object image first, फिर कनेक्ट करते थे. बताता हूँ कैसे. यहां से अगर मैंने एक लाइन लिया, फोकस से पास किया, I'll get a point here, जॉइंट. फिर वहां से मैंने स्केल रख के ऐसे नापा कि वन लाइन डायरेक्टली पासेस थ्रू, तो वहीं पे मिलेगा. शॉर्टकट है यार, डोंट हैव टू मेक इट, इरेज इट, देन डू इट अगेन एंड अगेन. सो आई एम गेटिंग द करेक्ट आंसर हियर, सिंपल एज दैट. आई होप यू गॉट दैट वन, isn't it? Yes, so between f and 2f2 you got it that. Okay, now at 2f, now obviously if the object is kept at center of curvature, I think we have a very standard diagram here. This is the only scenario in the entire universe when you have kept the object at c1. Let me make it at f1 here, and you have f2, and then you have c2. There's the only case in this scenario when you keep the object at c1, the image is going to form at c2, and this is going to be the same size and same length. So ultimately, even if I draw the ray diagram, it will be passing through this point only, isn't it? Okay, so C part also done. You have got basically one mark here, 2 marks for the D part. Let's check. What will be the nature of the image for the convex and concave lenses for case A and B? Okay, so if we take A and B, if you take only A and B, if I'm using convex lenses for both A and B, what would be the answer? ठीक है? Okay, so if I take convex lens for both, we have taken the convex lens for both, and what will be the nature of the image? Now in both the cases of convex lenses, for case A, it gives me a virtual image. For case B, it gives me a real image. Now for both the cases for concave lenses, I'm pretty sure concave lenses मुझे दोनों cases में virtual image ही देगा, because concave lenses cannot make a real image at all. Stated? Yes. That's all the answer you have to give, and this will carry basically 2 marks. That's all. बस इतना ही तो था. Now you have done 5 mark question. Let us check the answer as well for this question. I'm pretty sure the diagrams were correct. Yes, the diagrams were correct for all the 3 scenarios, and the answers for the B part were also correct. Virtual, erect and magnified, yes. Real, inverted and magnified, yes. Virtual, erect and diminished, virtual, erect and diminished for concave. Exactly correct, guys. You guys did a great job for this as well. Now in total for light chapter we have covered 5 marks, and for in human eye chapter we have covered 5 marks again. Now you must be thinking, sir, light से 7 marks से क्वेश्चन आने थे. हाँ, आया है, और जो 2 मार्क है वो जाने वाला है आपको होमवर्क as in this. It's a very simple practical based questions. If you read it very carefully, it's been stating in an experiment the image formed by a concave mirror is real and that of the convex mirror is virtual. What should be the position of the screen for both mirrors? मतलब स्क्रीन कहां पे प्लेस होना चाहिए, मतलब कॉन्वेक्स लेंस के सामने, कॉन्वेक्स लेंस के पीछे, कहां पे प्लेस होना चाहिए? इतना सिंपल है क्वेश्चन. दैट्स ऑल. वन ऑफ द बोर्ड क्वेश्चंस, एज सिंपल एज दैट. ठीक है, तो बताना मुझे इसका आंसर क्या होगा ऑन द कमेंट्स डाउन बिलो. ऑल्सो कनेक्ट आउट, रीच आउट टू मी ऑन द ईमेल इफ यू गाइज वांटेड. आई एम कंप्लीटली ओपन फॉर दैट ऑल्सो. ठीक है गाइज, सो ऑल द बेस्ट. दिस सेशन वाज आल्सो कंप्लीटली क्रेजी. यू गाइज डिड अ ग्रेट जॉब. आई एम सुपर प्राउड टू डू दिस sprint text 2 again. So amazingly well done guys. High five finally again. ये मारा बहुत बढ़िया guys. Thank you so much. Okay, and the answer for also that for is given. So if you notice right now we have covered light and human eye. We're left with electricity and magnetic effect solar current, which we're going to study in the next session coming down today. ठीक है, तो अब आगे बढ़ते हैं. So if you have not downloaded the app yet, you are losing out a hell lot of information and some amazingly crazy things like study material. You are missing out the classroom sessions. You are missing out the doubt, asking capability, because we are killing it on the doubt clearing part. If you have not noticed, just go ahead and just put down your doubt and you will see some extreme amazing results. Cool. And you can also find all these session videos, all these PDFs, all the solutions, everything, this session notes in the app itself. You can download it there. So what are you guys waiting for? Go ahead and download it, guys. That's it. Take care. So with that, once again guys, thank you so much. If you have not subscribed to the channel yet, subscribe to the channel, because we are giving out some crazy content this month, and hit that particular bell icon so that you are always notified whenever we come online. Cool. If you like this video, go and hit the like button, and also do share if you loved it. Okay? With that, that's my email ID. Reach out to me if you guys face any issues. I'll be always there with all of you guys. Okay? So इसी के साथ my dear students, we'll end up this session. We'll meet you guys in the next session soon today. So bye bye. Take care. Until we meet next time. Enjoy your life. Ta-da.